Hi students, in this video I'm going to talk about PERT network, PERT network. So the full form of PERT is Program Evaluation and Review Technique. In this case, the calculation of activity duration is a little different. The calculation of activity duration for CPM network is called deterministic time estimation, whereas for PERT the activity duration calculation of activity duration is called probabilistic estimation. So PERT network, CPM network is used for those projects where the duration of all the activities can be ascertained with certain with uh, more certainty, whereas PERT network is used for those projects where the activity durations are probabilistic in nature, and it is you cannot actually determine activity duration with a high degree of certainty. So the difference between CPM and PERT is only in the estimation of activity durations. Okay, so in case of CPM, activity durations are deterministic in nature, and in case of PERT, activity durations are probabilistic in nature, which means in case of PERT, in case of CPM, activity durations can be ascertained to a large degree of uh, certainty. With that means with greater certainty, whereas in case of PERT, the duration of each activities uh, cannot be determined with a high degree of certainty. So the activity duration will be probabilistic in nature. Okay, so in such case, uh, where the activity durations are uh, not certain, 3-time estimates are used for each activity duration. So these are called optimistic time estimate, most likely time estimate, and pessimistic time estimate. So optimistic time estimate is denoted by O, most likely time estimate is denoted by M, pessimistic time estimate is denoted by P. So these 3 time estimates for each activity Optimistic, most likely, and pessimistic time estimates are used to calculate what is called expected time estimate for an activity, or for each activity for that matter. Also, after calculating, after finding out these three time estimates for each activity, you also need to calculate what is called variance. Okay. To talk about the three time estimates in little detail, optimistic time is the maximum time that an activity could take to complete. So optimistic time is that time estimate which you feel that for a given activity, at the most, or at, at the most, it will take that much time. I think I made a mistake here. Optimistic time is the minimum time within which an activity could be completed. Okay, so uh, uh, if you feel that the if you feel that a particular activity will take at the minimum uh, that many number of days or weeks, for example, then that becomes the optimistic time. So this is based on the assumption that everything will go well. So assuming that everything will go well, uh, what is that minimum time within which an activity could be completed? So that is optimistic time. So when we talk about the assumption of everything going well, we are talking about normal level of effort being used with no extra shifts or personnel being used. Okay, and the most likely time is the normal time that an activity could that an activity would take to complete. So it is that time that would occur most frequently if the activity could be repeated. So if you can repeat an activity for 5 times, and upon repeating the activities for 5 times, uh, and the duration for completing that particular activity after repeating for 5 times, if it comes out to be 4 days, 5 days, 3 days, 5 days, and 2 days, then the uh, most frequently occurring duration is the 5 days, because 5 days is occurring 2 times when you repeat it 5 times. Okay, so that is what is most likely time. Pessimistic time is the maximum time an activity could take to complete, assuming that uh, the project come across bad luck at every step. Okay, so bad luck here includes only internal problems and not environmental problems like strikes, natural disaster, fire, rain, and all. So internal problem maybe because of people not putting in required level of effort, or there is a lack of cooperation, or uh, people not working in teams and all. So the bad luck here refers to internal problems. Okay, so not the natural problems like flood, fire and all. Okay, so these three time estimates, optimistic time estimate, most likely time estimate, can be then related to each other using what is called beta probability distribution function. So if you plot the three time estimates, you can see where they are located on the beta probability distribution function. So you can see the pessimistic time located here, optimistic time located here. On the vertical axis, you plot the probability of the time estimate, and on the horizontal axis you plot the activity duration. So if you plot the activity duration, then you can see optimistic time is plotted on this end, where along this axis you actually denote the activity duration. So here, for example, time estimate, optimistic time estimate 3, pessimistic time estimate 13, and most likely time estimate 5. So you can see, if you look at this probability distribution function, this most likely time has the highest probability, and this optimistic and pessimistic time has the lowest probability. So using this probability distribution function, you can actually have a function, and using that function you can find out what is called expected activity duration. So you can see these three time estimates, optimistic, most likely and pessimistic time estimates, is related in the form of this equation like this: optimistic time plus 4 times of most likely time plus pessimistic time, whole of this divided by 6 will give you expected or mean time of activity, which is denoted by small t e, small t e. So e is referring to expected time, t is referring to time estimate, expected time estimate of activity. So this is small v here, which is the variance of the activity duration, this expected activity duration, which is given by pessimistic time minus optimistic time, whole thing divided by 6 whole square. So with using these two formulas, you have to calculate expected time estimate TE for all the activities and variance for all the activities. Okay, then the expected duration of the project, which is denoted by capital TE, is calculated by adding the expected times of those activities lying on the critical path. Okay, using the formula capital TE, which is the expected project duration, equal to sigma CP small te. So expected project duration TE, capital TE, is equal to summation of the expected duration of activities falling on the critical path. Okay. Similarly, the variance of the project duration. Okay, here we are talking about project duration, not the activity duration. Variance of project duration also can be found out by capital VP equal to summation of variances of all those activities falling on the critical path. Then after that we can calculate what is called as standard deviate using this formula Z equal to TS minus TE under root VP, where TS is the target project duration, project completion time, which is given by the management. TE is the expected project completion time or project duration, which you calculate using sigma CPTE. Yeah, and this VP is here. VP is here. Sigma CP V, small v. Okay. Then using this, we can find out. Then using this Z value, we can find out the probability of completing the project using what is called normal distribution table. Okay, so we can take this example here. You can see for each activity 3 time estimates are given. For activity A, optimistic time is 2, most likely time estimate is 3, pessimistic time estimate is 4, and so on. Like for example, G, optimistic time estimate is 1, most likely time estimate is 8, pessimistic time estimate is 9, and so on. So using the value of optimistic, most likely, pessimistic time for each of these activities, we have to find out small te, expected activity duration, and small v, variance of each activity, expected time estimate of activity A, each activity. Okay, so as shown here, so you have to for each activity you have to calculate TE. Okay, TE using TE equal to O plus 4M plus P divided by 6 and V equal to P minus O divided by 6 whole square. So for each activity you have to calculate TE and V. Okay, so this one is done for you here. So for you can see for all of these activity or each of these activities, TE is calculated using these values. 2 plus 4 into 3 plus 4 divided by 6, so you get 3, and V you get by 4 minus 2 whole thing divided by 6 raised to 2 will give you 0.11. So like this you can calculate, and then network diagram is not there in this. Okay, so Then after that, what you can do is you can use this value of TE, which is the expected activity duration. Yeah, expected activity duration for each activity are here. Okay, for activity A, the activity duration is 3, for B it is 2, C is 6, D is 5, like for similarly G is 7, J is 4, and K is 6.83. So using these time estimates, you can actually draw the network using this precedence network. Okay, so you can try the network yourself. Okay, I think I will stop here and maybe show you later how to calculate the z value and find the probability in the next video.